for the equations involving absolute value, we just want to observe, I just like to look at example 1. What numbers can you think of that have an absolute value of 5? 5 and negative 5. Basically, absolute value is the positive distance between a number and 0. So if it's a positive number, it's just that number. If it's a negative number, well, to measure the positive distance, it would be what you get when you multiply that number by negative 1, because it's negative, but you need to make it positive. So the two numbers that have, suppose A is a positive number, the two numbers that have an absolute value of A are A itself and the opposite of A. A units to the right of 0 and A units to the left of 0. So to solve an equation like the absolute value of x equals 5, I'd want to do one step where I write an equivalent statement without the use of absolute value. Just take whatever's in the absolute value bars and declare that to equal that positive number on the right-hand side, and then write the word or, and then declare it to equal the opposite of that positive number on the right-hand side. If that's all there is to it, then that's all there is to it. You write the solution set 5, comma, negative 5. Sometimes there's a little bit more to it. If we have the b part there, the expression inside the absolute value bars, that's more to it than just saying the absolute value of x plus 2 is x plus 2 and throwing away the absolute value bars. What we want to say is this will be true if whatever's inside the absolute value bars truly equals 5, but it'll also be true if whatever's inside the absolute value bars equals negative 5. If we can search and find an x that we can add 2 to and get negative 5, when we take the absolute value, it'll equal positive 5. So, two possibilities. The first one, what number can we add 2 to and get positive 5? Whoops. Thinking 3. But I'm writing the wrong thing. Sure. We can add 3 and 2 and get positive 5, and positive 5 has an absolute value of 5, so 3 would be a solution to this equation. On the other hand, what number can we add 2 to and get negative 5? Negative 7, and we find that by subtracting 2 from both sides. So negative 7 plus 2 equals negative 5, and because negative 5 has an absolute value of 5, it satisfies the equation. So two solutions here, 3 and negative 7. All important first step though, we want to be able to rewrite this as an equivalent equation without the use of absolute value. So take what's inside, set it equal to the positive number on the right hand side. Take what's inside, set it equal to the opposite of that positive number, and that does it. The C part, is there a C part? Ah, C part and a D part, good. So a little bit more going on inside the absolute value bars, slightly less obvious what the final solutions might be. So we need to find an x such that negative 3x plus 7 equals 5. That's one possibility. If we find an x that makes that happen, it will satisfy this equation because 5 has an absolute value of 5. Or, failing that, if we could find an x that we can multiply by negative 3 and add 7 and somehow get that to equal negative 5, that would also work because negative 5 also has an absolute value of 5. So we're taking what's inside the absolute value bars, declaring it equal to the positive number on the right-hand side, writing the word or, and then declaring it equal to the negative of that, opposite of that positive number on the right-hand side. Two equations to solve. 2 steps for each equation. Divide both sides by negative 3. Observe that a negative divided by negative is a positive. So if I solve that 2-step linear equation correctly, that's 2/3. And the other one, subtract 7. Copy the negative 3x, copy the negative 12. Divide both sides by -3. So +4 is another possibility. So 2/3 makes the expression inside the absolute value of r is equal to 5. 4 makes the expression inside the absolute value of r is equal to -5. But either way, absolute value equals 5. So each one of these satisfies the equation. The D part is the tricky part. I don't know if I have one of these tricky ones on the practice test. Probably should. But could be one on the actual test, so be alert for this. What number can you think of that has an absolute value equal to -5? It doesn't. How low does absolute value go? 0, but no lower. So there's no number that has an absolute value of -5. So pick an x, any x, multiply by -3, add 7, take the absolute value. You will not get -5 as the answer. So that's the empty set. Yes.
Okay, so basically you can only work an absolute value equation if it is set to a even or set to a positive number.
Yes, positive, and I guess we should do this example as well. Definitely we can't do it if it's absolute value equal to a negative number, but suppose you had absolute value of 3x plus 7 equals 0. That's, I guess, the case we haven't considered. We considered +5 on the right and then -5 on the right. But what if it's 0 on the right? What would we do? What number has an absolute value equal to 0? 0. So I think we can write an equivalent statement without the absolute value, just like that. Because if we can find an x that we multiply by -3 and add 7 and get 0, when we take its absolute value, it'll be 0. So it'll be something like this. Subtract 7, subtract 7. -3x equals -7. X equals +7/3. That would work, and that's the only solution that would give you something where the expression has an absolute value of 0. So you can do it if it's 0 and has a little bit different feel to it, just can't do it if it's negative. Empty set. Or you can write it empty braces. Ooh, those are some rough looking empty braces there. Try again. There we go. Empty set braces. And time for one more, possibly so. Yes, we've got one more possibility. Suppose we've got two expressions equal to each other, and each one is the absolute value of the expression. So we've got two expressions. Think of as two numbers. Under what circumstances could two numbers have the same absolute value? I have a number over here, a number over here, and these numbers have the same absolute value. What's one possibility? They're the same number. They're the same number. They definitely have the same absolute value. What's the other possibility?
Whatever, however they're set up is going to be the same zero.
Well, suppose I've got a 5 over here. It could be I've got a 5 over there too, and they're the same number. But suppose I have a 5 over here, and there's another number that's not 5, but it has the same absolute value as 5. It could be -5. So maybe the numbers are the same, and they'll have the same absolute value, or maybe they're on exactly opposite sides of 0 but the same distance away. So maybe they're opposites of each other. So maybe they're the same, or maybe one is -1 times the other. Those are the two possibilities if two quantities, two expressions have the same absolute value. Either they're the same or they're their opposites. So here, if I wanted to write this as an equivalent statement without the use of absolute value, I could write it like this. But that's not the only possibility. It could also be that x minus 7 equals the negative of x minus 5. Maybe they're the same. Maybe they're opposites of each other. I don't know, but either way, they have the same absolute value. Turns out they're not the same, because if I subtract x from both sides, I get -7 equals -5, which is a contradiction, which means that portion of it has no solutions. Because -7 is not -5. But over here, we get x minus 7 equals -x plus 5. So we can add x to both sides, and we can add 7 to both sides, and get 2x equals 12. So maybe x equals what? 6. 6 minus 7, that would be the absolute value of -1. 6 minus 5, that would be the absolute value of +1. So whereas the expressions inside the absolute value bars are not equal, their absolute values are both equal to 1. So 6 makes it true. How about over here? It could be that 2x minus 7 equals x minus 5. Or, failing that, it could be that 2x minus 7 equals the opposite of x minus 5. And both of these have solutions. Subtract x, add 7, add 7. It could be that x equals 2. What does 2 do? 2 times 2 is 4. 4 minus 7 is -3. 2 minus 5 is -3. Yeah, I believe 2 works. What's the other possibility? 2x minus 7 equals -x plus 5. If we add x to both sides and add 7 to both sides, we get 3x equals 12. At least they're nice numbers here. Running through these at light speed. At least they're nice numbers. No unsightly fractions. X equals 4, it looks like. What does 4 do to both sides? 4, 2 times 4 is 8. 8 minus 7 is 1. 4 minus 5 is -1. So 4 does not make the expressions have the same value, but it makes them have the same absolute value. So 4 makes it true as well. 2 solutions here, 2, 4, whereas this one just had the 6. Yes, thank you for that. It was good to get through with that. Absolute value inequalities next time.